Hello, everyone, and welcome to the All Things Tech podcast, episode 3. Uh, Today, we're going to talk about artificial intelligence chips. So we go hard on hardware. And it's your host, so Mitko.
Hi, everyone, and this is Shabazz.
Hi, Shabazz.
Hey.
So maybe we should start actually introducing to the audience what's AI chip?
AI chips. I mean, as far as I'm aware, like they can include things like GPUs, obviously, like NVIDIA for sure, but also even FPGAs now with the AMD Xilinx type. They're into that, so combining FPGA functionality with AI. So for training models and for inference, basically, those are the kinds of tasks that you'd want to do. But also there's custom silicon as well. So, GPUs, FPGAs, custom silicon, and also it depends on the space that these things are operating in as well. So whether it's data centers or edge or endpoint compute, they will have different requirements in terms of the performance that's needed and the power requirements. There's lots of interesting stuff going on, and there's a lot of orgs out there that are worth looking at now, aren't there? It just seems like this is going to explode in the next 4 or 5 years. The amount of investment there is going on in AI chips.
Yeah, even today, I mean, I have counted 154 startups and established companies actually building AI chips, any kind of sizes, and as you said, training and inference.
Yeah, that's brilliant. And I only know a handful of these companies. So it's going to be like fascinating to actually read up on and learn about a lot of these other companies out there that are working on AI chips. Yeah, sure.
I think with you, we actually have started working with these AI chips focused companies a long time ago, before there was no AI chips, kind of like a term. Maybe you can talk about our personal story with Graphcore.
Yeah, so Graphcore, for anyone who's not isn't aware, they've got a processor called the IPU, which is intelligence processing unit, and it's more for data center use. And originally we spoke to the CTO actually at the time of Graphcore. And he mentioned that. So this is going back, I don't know how long ago.
2015. I think there was no Graphcore at that time. They just had the idea, and they asked us, "Hey guys, can we kind of pass an idea and get your opinion on that?" And I think it was both of them actually, the CEO and the CTO. They've been still working at a different company, or they've been just transitioning. So 2015, we had this session with them, and they're like, "This is the IPU," and what? What's an IPU?
We didn't have a clue. Like wondering what on earth it was.
8 years ago, it was either 2015 or 2014, way before there was any kind of traction around AI. And
I remember
AI
that
hardware.
specifically because that guy was so passionate, Simon Knowles, about it. And like he had that vision, right? That kind of processor is going to get important, and and that was going back so far ago. And also, it just always like fascinates me, like when CTOs, they know their products like down to. Yes. It wouldn't surprise me if you knew it down to like logic gate level, like on the chip. Like, really passionate and can like deep dive into the technical detail. So that was pretty
I also remember that session. That was, I mean, I don't remember that many things 8 years ago, but that one specifically I do, because I'm with you. I was really impressed. Like, wow, these guys, they're really passionate in the things they do. And I was sure that they're going to be super successful. And we've been right. I mean, they are super successful. Did you have any recent experience with Graphcore?
Only in terms of trying out the IPU. Obviously can't afford like one IPU, let alone the many that might be needed for training. But you can. There's a free online capability, so you can log on and make use of it for 6 hours at a time, and
Okay.
it's totally free. So as many 6-hour sessions as you need, and they've
Wow.
got like a training course stuff there. So I did actually try going through the training on it, and unfortunately, for me, it crashed. Not the
No.
IPU, but I mean
No.
yeah, it kind of hung on me the environment which I was using. So I do need to reach out to them and figure out what was going on there. And then I made the mistake because, like, obviously, in the training for massive models can take hours if you don't have many IPUs. And I had obviously the free option doesn't give you much, so I was using that. And although you can pay if you want as well, and then start using more IPUs. So yeah, after about an hour, a couple of hours or so, I kind of hit the reset button without saving.
No.
Yeah, redo that. But I'm going to redo it because it was like super easy to go through following their tutorial.
Okay.
So that, yeah, definitely interesting to do. That's the website is Paperspace.
Okay, Paperspace. And did you use your own models, or you use models built by any platform, like HuggingFace
They
or
actually
something else?
have their own model. So the data set that they're using is for NLP, so natural language processing, where what they've got is a bunch of extracts from Wikipedia,
Okay.
along with questions. And what they're doing is they're saying, well, okay, if this question gets asked, which snippet of text or which words from within the Wikipedia articles would provide the answer. So that's what you're training on.
Okay. So you've got the model from HuggingFace, and then
Yes.
sorry, you've got the data set from HuggingFace, and then you actually went to define the model on Paperspace.
Yes, exactly.
And it's totally free, both of them?
Completely free, yeah. I mean,
Amazing.
yeah, amazing, really. I mean, when you think about it, just compute away, and maybe I don't know if it gets tied up if there's contention with other people, but
Okay.
there certainly wasn't when I was using it. I mean, I had the full 6-hour block, for as long as I wanted.
Okay. So when people complain they don't have enough resources actually to get started in their career in AI, I mean, they maybe don't look in the right places. So HuggingFace for the data
Yeah,
set,
exactly.
Paperspace training the
And
model.
you could use it for other things if you really wanted to.
Yeah.
I mean, it's there for free. I mean,
Any
and
other
it's
things? Like what else? I mean, share some ideas.
well, because it's using the Jupyter Notebook style
Mhm.
thing. So yeah, I mean, if you wanted to, there's nothing actually stopping you using that environment to do any coding that you want to, just to try things out. Seem pretty responsive
Oh, yeah, nice.
when I use it. Yeah.
And how did you know how to use the Graphcore system? I mean, was there some material that you read about or YouTube videos? I mean, what was your path? Maybe that's going to be very interesting for the listeners.
Yeah, a good question. So there's obviously like a SDK. I
Hmm.
think they call it Poplar. I think,
Okay, Popware. Yeah.
yeah, Poplar SDK. But I mean, I was more curious also, like at the chip level as well. Like, what are they doing? How are they getting the performance increase and everything? So they got like it's not even a white paper. It's like really in-depth document that you can download for free. It's like a book level, like 100 pages
Wow.
of technical information on their chip
There
and
is no
how they
TikTok for 100 pages document.
yeah yeah no 60-second thing there, unfortunately. But yeah, so that explains in detail how they manage it. But yeah, the performance is immense because they've got massive, I think like 1,700 or thereabouts, like cores inside there.
Wow.
And yeah, the throughput as well is huge. They have I think it was 11 terabytes per second of like fabric inside there, non-blocking
Okay.
and also tons of memory. So each tile, they call it IPU tiles,
Okay.
intelligent processing unit tiles. So there's 1,472 tiles. Each has got 900 megabytes of memory and 6 threads per tile. So that's about 8,000-ish threads on a single. Oh, and I mean, I guess some of that history must have come from XMOS, right?
Yeah, I think they've been at XMOS the first time we've met them. At that time.
Yeah, because for anyone doesn't know, like, I mean, we used XMOS. I mean, that was like super interesting because because you remember, like, when we were working on being able to take legacy protocols and convert them to IP ones, then you need to have the protocol conversions, and obviously some things like I2C and SPI, there's that, but there's industrial protocols, and the XMOS chips were kind of good for that because it was really great for real-time stuff, hard real-time stuff you could do with the XMOS. And the reason why it was so good for that is because when you've got like an operating system, real-time operating system on a CPU, XMOS was doing pretty much that. The XMOS chips are like processing cores, but also having the real-time operating system in hardware almost. So where in the OS you might create threads, well, they're actually cores on a XMOS chip, and where you might have like that inter-process communication, that's actually using like almost like a fabric that they've got on their chip.
Okay.
So doing in hardware what people would normally do in software. So yeah, that was pretty impressive stuff. So I'm guessing that's where some of the IPU ideas came from as well.
Yeah, I mean, I think we've been using their microphone arrays actually, even in our startup in the past.
Yes. Yeah.
Yeah. I mean, I love their designs. Like 2017, when we have been building our own hardware piece for smart buildings, they've been the best choice. I mean, for sure.
And I think for audio, they still are as well. Like, yeah, they obviously. I'm sure Amazon Echo devices, some of them use XMOS parts inside there.
Yeah, I remember when you disassembled one to see how it looks, and then there is no way back. You cannot put it back.
Yeah, that is impressive. I mean, yeah, I've not opened up any recent Amazon devices, but that one, yeah, it was like alien technology. The way they'd managed to compress so many circuit boards and everything all into that one tiny unit.
There is no way back. I mean, once you open it, you cannot. I think the same is for the 3D wafers that Graphcore has, this wafer on wafer technology. I mean, if you see the complexity they have, I mean,
amazing. Yeah.
If you tamper with it, that's done. That's like literally done.
Yeah, it's amazing. Yeah, for anyone who's interested in, like, the computer architecture type stuff, I mean, that must be a delight to learn about that chip, the IPU.
Just don't open them because you cannot.
Yeah. Well, also the price, I don't even want to know how much they cost.
Yeah. Reach out again to them and ask them, okay, do you have some systems that we can actually use and provide more materials, more training materials to the field?
Yeah, I know. Sure. Yeah, we should actually. Yeah, maybe try reaching out.
Yeah, we should totally. I mean, we should totally write them because 6 hours is not much, especially if you want to kind of work and these large models lately, like large language models and everything that gets a lot of attention. Obviously, you need a lot of hardware to do that.
Yeah, exactly. Yeah, lots more IPUs. Yeah, sure. Yeah.
So we went over the big machines, but then the edge computing is very close to our heart. So what about like the endpoint AI? Anything on the small devices? Not much of energy consumption, but perfect for inference.
I think for like anyone who's like wants to like start experimenting now, like in terms of like the cheap, really cheap low cost options, the Kendrite K210 is, really still worth looking at. I mean, it's quite an old chip now, so it doesn't have that much performance, but it's cheap, and you can buy from Seed, for example, or there's a product called Cipede makes Duino.
Okay.
Crazy names, but yeah, it's like an Arduino basically, and it's got this Kendrite KT10 chip on it, and with that you can program it in Python, and they've got this, I think they call it Makes IDE, with the development environment for it, and obviously it's like any standard IDE, but also you can bring up a view of, like, if you've got a camera attached, for instance, if you're doing image classification, then you can actually see the real-time camera view in the IDE. You can also see the CPU loads and things like that. So you can start coding and actually see all that info there. And it's really cheap, like £20 or something, $20, $30, something like that. That's dead easy to use with Python as well. Comes with lots of nice examples. But in terms of like other like more interesting chips, there's like with ARM, for instance, so there's a Cortex M55, announced a couple of years ago now. That looks super interesting. I'd love to see some silicon for that, which I haven't actually at the moment. I don't know of any manufacturers that have developed chips with that core, apart from Aleph Semiconductor, and their chip looks super interesting. They've got like I think 4 series of chips.
Okay.
Like 55.
And that's the best. You can all buy them. You don't need to know the CEO. Like I know the CEO of Seed Studio. So Eric Pan, he was in Berlin, and he always has all these crazy gadgets in his pocket. At that time, he showed me like folding phone, and the phone was made out of paper. So Seed was thinking like to productize them. And I mean, you don't need to reach out to Eric to get samples. You can just go and buy them, because as you said, like it's 1, 5, 10, 20, 60, $100, and
it's brilliant. Actually, I do like Seed store.
Yeah, me too. I mean, I have a lot of Seed at home. I mean, and I bought a lot of it. Some of them were presents, obviously. So these are the really cool endpoint AIs. And anything around the ARM, obviously.
I mean, that M55, it's what was interesting was, do you remember like with the A series, the applications processors, Cortex A, they used to have this, well, they still do, they have this thing called Neon, which is the single instruction SIMD, single instruction multiple data. And what that does, like for anyone who's not aware, is it's acceleration for maths, basically. So where you might want to do simultaneous operations, that's the multiple data bit. So they've got like really wide data bus for that, or really wide registers, sorry. So they might have, they've got like 128-bit wide register, and you can split that up. So if you've got data that's like 16-bit wide, for instance, then you can pack 8 of them into that 128-bit register, and then you can do things simultaneously. So you could say, okay, I've got this 128-bit register, and I've got another one, and I want to multiply each individual element in there. So all the 16-bit wide data that we've got in there, multiply them all simultaneously, or add them all simultaneously. So you can do DSP type operations, and get lots of fast maths acceleration. You don't need to know that detail normally, because whichever software, whichever programming library you're using, maths library in C or Python or whatever, that will normally have that already built in. But that was in the Cortex A series. But now they've got something like that, but in the M series. So the M55, obviously the microcontroller kind of series, but they're not. It's not called Neon. It's called Helium.
Okay, new name.
Yeah, the gases. After that. But yeah, it's kind of like Neon, but a lot more instructions. 130 new vector instructions, I reckon. And so that's how they're getting some performance improvement for AI. And also the other thing that they reckon is getting their performance improvement is memory. So they've obviously got normal cache to handle like any external memory access delays, but also they've got this like tightly coupled memory interface. And they reckon the performance increase looks huge. It's like almost an order of magnitude, like M4 and that kind of grade, or M7 even. So yeah, it's a huge leap in performance, and the idea is that those M55 chips, they can do it. For example, if you're doing like a Amazon Echo type thing, then keyword recognition would use that M55.
Yes.
And then for the extra acceleration, so now actually doing speech recognition, so beyond the keyword recognition bit, that would be done by almost like a coprocessor that they've got called an MPU, which is a neural processing unit, and that's called an Ethos U55. I don't know where they get these names from.
Yeah, I'm with you. I mean, there is maybe someone who just had sitting in UK at ARM, and he's just figuring out new names.
Yeah, and for that Ethos U55, it's like a coprocessor, and it uses shared memory, I think, to communicate between the M55 and the U55. So you write to RAM and you read from RAM. So that accelerator does like AI neural network acceleration type stuff. So any neural network low level functionality that would get accelerated by that U55.
Yeah, that's the thing. That's what I see. You have all these AI code chips where you have obviously certain functions running on the like microcontroller or CPU, NPU, and then there is a lot of these AI code chips that do the heavy duty lifting of very specific functions like natural language processing or some video processing like machine vision models.
Yeah, and I mean the new chips do look interesting. I mean, obviously, like only Aleph Semiconductor at the moment seem to have
Yes.
chip. I mean, I didn't find anything else, just like Googling. But yeah, they're obviously targeting that kind of stuff. So like automotive use, with cameras, also audio uses as well. But industrial, like home use, healthcare. That's the kind of area that they're focusing at, and they've got like four different chip ranges that use that M55 with that U55 capability as well. Ranging from just like a single core microcontroller, but also that the high end they've got a mix of Cortex A and Cortex M. But they claim that image classification is 800 times faster than any other Cortex M when they use that M55, and they reckon that M55 plus U55 is 78 times faster than M55 alone when it comes to AI functionality.
Yeah, it seems this packaging becomes now the kind of the de facto standard when it comes to any small device which needs to operate on effective energy and needs to do any kind of machine vision or kind of heavy language processing on the edge.
Yeah. And, also, get the I mean, I know nothing about Aleph Semiconductor, but just like Googling them, and their co-founders were actually one of the guys. His name is Syed Ali. He's a co-founder of Cavium.
No, okay. It's such a small world. Unbelievable.
Yeah, because I mean, obviously, like that any like networking company, they tended to use Cavium processors.
Yes.
And that they had like MIPS cores, like lots of cores. So back when compute chips didn't have that many cores, they did. They had tons of cores for like network processing type stuff. I remember we had like a dev board for the Cavium Octeon chip, and it was so. I mean, that was like a $4,000, I think, or £8,000, £4 or £8,000. I can't remember entirely now.
I think it was for the ASR series routers.
Yeah, exactly. I think just before the ASR series, I think they used that chip. It's a bit vague for me because I wasn't actually working on that at the time. But I do remember like sitting like alongside a guy who was looking at that Octeon chip back then. Yeah, which is pretty cool.
I remember everything now, kind of all these memories getting out of the back of my brain, because obviously both of us working at Cisco for a decade and something. Everything we talk about just gets back from the brain. Okay, I remember how it looks like, how it's connected inside the router, what functions are running there.
Yeah. And like for anyone interested, I mean, it's actually mind blowing, like what these chips do, right?
Yes.
Because when you're talking about like even back then, like 100 megabits per second, right? Not let alone gigabit processing. Like, how do you manage that? Writing normal C code and yet being able to process all these packets, and you have to have multiple cores. You have to have like accelerators for like network functionality as well.
At the
So
right
all of
price
these.
level. Yeah.
Yes.
Today, everyone is just thinking GPUs. GPUs is the new, mantra, and you can do everything on a GPU. You can do it on like very heavy frameworks, and then everything just becomes so expensive that it's tough.
Yeah. True.
If you don't look for options.
Yeah.
Okay.
Yeah.
So yeah, go on.
Sorry. Yeah. Let's move on. I guess. If there's anything else should we talk about some of the data center type stuff? I
Oh,
think that's more kind of your area.
yes. If it burns a lot of energy, that's me. If you need the power plant to power it up, that's me. Actually, when I was in Berlin, we have built a data center at that time, the innovation center, and we've got NVIDIA cards for the UCS series servers at that time, and they have been so expensive. And we have been running OpenStack as a kind of virtualization platform for the data center. And you couldn't use almost none of the NVIDIA functions at that time. It was 2015, so 8 years ago.
Right.
Yeah, so it was that was my first touch actually with data center hardware for operations. And obviously when you have to purchase it and everything gets out of your budget, and then also your team needs to operate it, you see all the details and all the issues.
Was CUDA popular back then, or was that come after? I can't remember the time frame.
It was, but it was doing baby steps. I mean,
Right.
obviously it was a lot around gaming, around visualization, 3D effects, and not so much about data, basically. 8 years ago, obviously there have been first tests to go and do some, to look to find some fancy models, etc. But just baby steps. It was a lot video related.
Right. Yeah, the whole idea of general purpose GPU came after, right? I guess.
I mean, it was there, just got kind of repurposed. And then obviously, shortly after, all the crypto bros discovered the GPUs for mining cryptocurrencies, and then everything just went bananas. Unfortunately, I think a lot of the science was hindered by that time, because all the GPUs have been mining coins instead of doing something about getting the humanity to become multi-planetary, or kind of discovering the generative AI earlier, not so late.
Yeah. And prices haven't really come down, unfortunately, right? I mean, there's still pricey bits of hardware. Unfortunately,
it's really pricey, and I think it's still dominated by NVIDIA by far. I mean, if we see all the big success stories lately, like OpenAI and everything else, everything is trained on NVIDIA. So all the models have been discovered on NVIDIA.
Right.
So they become like the oil for AI, like,
Who are the competitors? I mean, obviously, there's Graphcore to some extent, but who are the big players as well? Like,
I think
as well as the startups.
Yeah, I mean, if it's GPU, I think it's AMD. It's one of the big ones, which is competing with Graphcore, with NVIDIA, and then obviously you have tons of other companies now: Graphcore, SambaNova Systems, Cerebras. Then there are other startups going into photonics, like Celestial AI, and others. More of them are stealth. I think there are around 40 startups building AI-specific chips for data centers. like
But the
on-premises
photonics,
data.
do you mean like quantum compute?
No. I mean, just chips that you can use today, like wafer-on-wafer technologies, etc.
Right.
Yeah. So they want to compete with NVIDIA. Obviously, the NVIDIA is the behemoth, but there are 59 others who are also building something in that space. It is just the GPUs, and there are all the FPGAs and all these kind of fancy designs popping up.
Yeah, that AMD competition is quite interesting, right? Because they're obviously making use of their FPGA history with the Xilinx for their chips.
Yeah, like Intel. They also launched the Arc series just recently. And I mean, we have our personal story with Intel, and maybe we can share it now in the podcast. So when when we had our own startup in the past, we have been using IoT chips from Intel. So Intel Edison. I still actually have a jacket somewhere here, one Patagonia jacket with Intel IoT Edison. What you're gonna make today?
I still have an Intel IoT umbrella. I still use it actually. It's really nice. I think you gave it to me.
I guess so. I mean, we've been so hooked, like, oh, Intel is going in IoT chips and etc. And we have built, I mean, the C3PO design that you have created, and then we actually have built manually with you and with Samuel in Slough. I mean, we've been running on Edison, so we've put our money, we've put our time, believing that Intel is gonna do big in Internet of Things chips. Well, it didn't. Intel just killed it overnight without any major kind of warnings.
Yeah, that was depressing.
It was depressing. I mean, he spent so many months. We actually have built these devices. I mean, I was putting the paste on them. Samuel was kind of doing the manual taking place. Unbelievable.
Yeah, I mean, for anyone interested, I mean, that's we were trying to literally do hardware and software, all of it from scratch.
Yes.
And so for all of us, like actual pasting circuit boards and sticking them in hot air ovens and reflowing and doing all of that was like completely new, right?
Yeah.
And I still remember, I think you did the first paste, and I remember looking at one of the online resources, some company, and they were explaining how to do that.
Yeah.
And they were saying like, oh, it may take you like 20 to 40 attempts to get it right. And you got it right first time.
Because we only had 6 boards. Amazing time. So, Intel, when you speak about Intel, I think they should be only in a sentence with CPUs, because if you take them out, like RISC-V, I had such a kind of expectations from them, like new CEO, and Intel said, okay, now we're going to take RISC-V and we're going to get it and make it so strong as an ecosystem as ARM. So you're going to have all these choices. And then they just killed it end of January this year, like without major announcements, without any, so the same what they did in the past with the Edison to us now actually happened with the RISC-V. So
oh gosh, yeah, that's disappointing.
yes.
Yeah.
So Intel Arc GPUs, I will be careful with that and betting big on them. Frankly speaking, I don't have any other details, but just because we both got burned from this, and
yeah. I mean, luckily for us, at least, we quickly moved, and the reason we were able to do that was because both of us, we were really familiar with the BeagleBone Black.
yes.
Do you remember? Because we used that for a different project, so yeah, we were able to port the code across and start using that. But yeah, all that hardware, all that nice hardware we built for the Intel Edison, it's just depressing that we had to kind of essentially throw that away. I still got one of the boards somewhere.
Yeah, me too. I have like 2, and they can go in the history museum of Intel doing something else than CPUs.
Yeah.
That was the learning. But back to the hyperscalers and the data centers. Obviously, in many cases, what I have seen, almost every one of the big 3, like AWS, Azure, and Google. They have their own chips, their own custom silicon.
Yeah.
So obviously GCP, they're famous with their TPUs, and then there have been kind of own developments both at AWS and Azure, where they're running the big platform as a service for training models like SageMaker or AutoML. But I think that trend is not going anywhere further because NVIDIA won. So my take, it will be that all this custom development is going to go dust this or next year, and then everyone is just going to use NVIDIA.
Right.
They're so popular. It's unbelievable. If you speak with any data engineer, if you speak with any data scientist, everyone knows to use the CUDA API. Everyone is so much hooked to them from university or from any kind of online training that they have been through that nobody is looking lately for any other choices when it comes to kind of big machines. Everyone is just hooked on NVIDIA, and that's all.
What are the like if people want to get up to speed with it, like what are the best like services to use, like to have access to them? Because obviously it's kind of hard to buy that, and you do need a fairly modern PC, I guess, to have the right GPU, and you might not have enough resources on your PC at home for using that.
I think Paperspace is a good choice. Still, if you want to bet big, I mean, definitely building your own PC with the right GPU is probably the cheapest option because obviously you're going to use it extensively for learning and self-education. So you can create much more value out of that hardware, not just for gaming. Like my kids, if you give them GPUs, it's just gaming. I mean, they don't see any value outside of gaming. But definitely, if I have to be kind of honest, and if I want to learn a set, I would prefer to have it under my desk.
Okay.
Obviously, it's an asset. I need to ask my wife for permission to buy it. But once you buy it, you can easily use it for several years, and you can do a lot of kind of self-education, self-training. This is the best way. I mean, you cannot just read it. You cannot just read the.
No, you have to. Yeah, exactly. Get your hands dirty, right?
Actually, yeah. That's a must.
Yeah, you have to recommend some GPUs to me because I need to get a new desktop at some point. But I know nothing about what's out there at the moment in terms of even CPU cards, let alone which GPU to get, what kind of power supply to put in there. And this is all kind of new to me because I've used laptops for so long.
Yeah, we can do it together actually.
Yeah.
Maybe NVIDIA, they can give us some free GPUs so we can get better. And again, we are not paid by any of the vendors we mentioned on the podcast. It's purely based on our own experience and our own vision. So, but if they have some GPU fall out of the track, we can take it.
Yeah, actually, even their edge processing stuff, because they've got their new Jetson Orin, I think it is.
Yeah,
Jetson Orin. Yeah, that's just been released, right? And I think they're like the development kit is a bit expensive, unfortunately. I think it's like $2,000.
Okay, well, that's a lot.
Yeah, but yeah, that would be interesting, I think, as well to try out.
I actually have one Nano at home. I have several dev kits. I think I have the old TX2s. I mean, I have several of them. Then I have one Nano. Right. Yeah, I mean, obviously I don't have Orin because it's too expensive. And I think you need them for very specific edge functions. Most of the time, you can just use GPUs, like the general purpose ones, obviously with enough memory. So you can experiment on more.
Yes, exactly. Yeah. No, I totally agree.
And again, it's just scratching the surface. Is obviously working with data and language models. And think about the metaverse. I mean, the real metaverse, not the crypto one. So we don't discuss the crypto. We don't want to go into that direction. But the metaverse itself, if you want to do rendering, if you want to go and experiment with all these visualizations for enterprise or industrial use cases, there is nothing better than the GPUs to do that. And we have our friend Axel, who is all into the industrial metaverse. and he's doing a lot of interesting stuff actually with the GPU on his desk.
All right, interesting. Actually,
Yes.
I'm super keen to learn about the metaverse as well. So, and I know you and Ax have been doing a lot on that.
Yeah. Let's do an episode. Let's do an episode.
let's definitely.
Okay, done deal.
Excited
Next
about
episode is going to be metaverse.
Brilliant.
Yeah, because again, I do agree that now there are hard times. 2023, 2024 are very hard times. So everyone's focusing on the core business. I mean, things that actually make money, not so much experimentation. But what we expect that 2025 onwards, it's going to be good times. I mean, so we're in the hard times, but they're going to end in a year or two of now. And if you want to be ready for the good times, you have to build today. So if you want to be going into any kind of large language models, generative AI, metaverse, you have to build it today. So you actually have it ready in 2025 when everything restarts, the market is up, everyone wants to go and innovate, experiment.
Yeah. And any I'm just wondering, any tutorials or books? I know books can be outdated really quickly. Like, for people who want to train and learn, or videos even that are worth using. I mean, I use acad.guru a lot. I really like that site. I mean, but that's not really for AI. But yeah, I'm just wondering what kind of good books are out there as well. I've got a couple of AI books.
It is a mix. Actually, a month ago, Andrei Karpathy did 2.5 hours YouTube video on how to build your own ChatGPT, like the whole model. And he went on all these details, and it's for free. You just need to invest 2.5 hours.
Okay.
Obviously, you need to do some prep work and then watch the video. It's amazing. I mean, how much know-how the guy just shared. He like really the cutting edge stuff, fully free. And
that sounds brilliant. Yeah.
That's beautiful. Maybe we should put actually the link in the
yes, please, yeah.
We'll put it in the notes. Also, the good thing is that most of the universities now actually have their programs online. So there are like Stanford and others
Of
actually
course,
posting. Yeah, they have all these courses. Obviously, you don't get the Stanford diploma at the end, but you can have months and months of everything from linear algebra going to mathematics, statistics, all the details up to anything with the new fancy large models, how to use the tools. These are months of education fully free. I mean, for me, the best education today is actually online and it's free. This is the best.
Brilliant. Yeah, that I suspected that would be the way to go, because books are getting outdated super quickly. I mean, I'll buy a book, and by the time I actually get around to reading it, it's like, oh, actually, there's a new new book out there now that's probably better.
Yeah, I mean, obviously, books they have their charm and they have a lot of history there. Like, did you read Chip Wars, the book that?
Yeah, you recommended that. That was I really like that book, and especially because like you said, that's explaining like the history.
Yes.
So that was great, and that's definitely worth reading. It's quite light, easy reading. Yeah.
I'm a big fan of actually reading the history, and today in the podcast we discussed so many things that we knew how they work and etc. for decades, and they are just now getting repurposed and they're becoming AI chips. So a lot of from the DSP world, a lot from the FPGAs. Now that everything is just repurposed, but it was 10 years ago. It's the same. It's just the same. It's just new software, new way to address the hardware, new ways to use the memory, high speed interconnect, photonics.
Exactly.
This is the new ways, but everything else is there. So understanding the history actually helps a lot going into the future. And that's also something to the listeners, something that they see. A lot of the superstars today, they don't go into the details. So they don't look on the hardware itself, like I/O, memory, power consumption. And they miss it, and they just go and use frameworks, and they do these bulky ways to kind of work with the data, train the models, and everything becomes so expensive because nobody pays attention to the underlying hardware infrastructure, which actually many times it's underutilized only because people don't look for the full stack. Like they just stay on the software side, but nobody looks on, how to optimize the firmware, how to optimize the hardware, how to optimize your networking design, because all these AI, chips, they're not standalone. We see them in distributed systems. So doing all these optimizations on the lower level actually makes it ultra effective to utilize everything you have.
Otherwise, you could be coding something and not realize that that's exploding out to like a lot of cores, or lots of hardware being used for one tiny little thing, which is consuming up all of the resources.
I've seen it with engineering so many times, and it happened actually over the last couple of years. People started to choose the easy path. So they just look on some small tutorial and TikTok videos, and then just go, okay, let's go and use Jupyter Notebook, and let's do this, and that. But they don't look on all of the details, and everything can become very expensive very fast. That's the reason you have achieved so much with these 6 hours free on Paperspace, and someone would need, let's say, $10,000 budget to go and build exactly the same on a cloud provider.
Yeah.
And that's the thing. Data centers definitely. I think everyone's moving from custom silicon to much more general purpose CPUs. And again, the big movers are going to be obviously generative AI, because now everyone's going and putting Gen AI loads, training and inferencing models. And the metaverse, because it's going to hit like a storm in 2 years of now, when everyone relaxes from the economic crisis. And people have to build today, so they're ready for 2025 for the good times.
And also, I think, as well as that, all the network connectivity and, mobile data connectivity as well will be like super important for metaverse. So be interesting to hear or to learn about what's going on with next generation mobile networks as well, to support the huge quantities of data that will be needed for the metaverse.
You have the chips already built in. I was running my own 5G core, so I had one of these Azure 5G private cores, and it's running on one rack unit server, where I had
way,
right? Yeah,
amazing.
It's amazing. And on the server itself, you have 2 NVIDIA T4 cards built in. And one rack unit server is a full mobile core. So you can register SIM cards. You can actually kind of terminate 25 gigabits a second mobile connectivity on single rack unit server. And you have AI chips on top of it. You have GPUs, so you can do a lot of really fancy stuff on ultra low latency next to all these mobile devices.
Incredible.
It is. It is. What a time to be alive. So I think anything else that we should add to the AI chips, or we can get ready for the metaverse discussion next?
I think no, that's good. Sounds good to me. Yeah, let's do that.
Okay, so thanks, Shabazz. You did a lot of homework, and all the discussions and all the personal experience actually was a lot of time invested by you. So wow. All the things you did actually to experiment.
Pleasure doing that. And plus, obviously, we've worked on some of this stuff, like you mentioned with our startup.
Before it was cool. We did it before it was cool. So the people
so we're kind of invested in that. We're passionate about it, right? Yeah, that's good.
Yeah. We have to figure out what's going to be. Yeah, likewise. It's always a pleasure talking with you. And we can get ready for the metaverse discussion next.
Excellent. All right.
So,
thanks, everyone.
Thanks, everyone. That was the AI Chips podcast today with all things tech. If you want to give us any additional feedback, you know how to find us. We are on Spotify, we are on Apple Podcasts, and we are on Anchor FM. So we have 3 platforms where you can go listen. And we are always happy to get your feedback, to get your questions, or if you want to be our guest, just reach out to us. So thanks a lot, everyone, and goodbye.
Bye.